Hello there. Welcome to section 5 of unit 3. And in this section, we'll be looking at white light, their definition, sources, and the spectrum. Let's look at the objectives of this. The first one is to understand the nature of the electromagnetic radiation. Secondly, also understanding the nature, source, and spectrum of a white light. What is an electromagnetic spectrum? So the electromagnetic spectrum is comprised of a variety of types of electromagnetic waves, each with different wavelength or frequency. So when you look at the electromagnetic spectrum, there are three things that we can use to distinguish them. That is their wavelength, their frequency, and the energy. And there are so many types of electromagnetic radiation, like the radio waves, microwaves, infrared radiation. We have the visible, the UV, X-rays, and the gamma rays. And there are so many applications of these electromagnetic waves. Not leaving out the radio waves, where it helps us in our so many communications. Our microwaves that we can use in our kitchens and other places. The infrared and the visible UV, X-rays in the hospital, and the gamma rays. So let's talk about a white light here. A white light is defined as a complete mixture of all the wavelengths of a visible spectrum. This means that if you have a beam of light of all the colors of a rainbow and focus on one particular spot, let's say through a prism, we have to able to obtain a white light again, as we demonstrated in our previous sections. There are two main sources of a light, and it can be either natural or artificial. The natural one is the one example from the sun and the stars, or from animals like the fireflies and others. And the artificial ones are the ones we can have in our homes, the LEDs, the incandescent bulbs, and others. Let's look at the spectrum of light here. I told you in the previous slide that a spectrum can be characterized with either the wavelength, their energy, or the frequency. When we disperse a white light into different colors, we can classify each of them into a particular wavelength. And here, violet has a wavelength from 380 to 450 nanometers. And that of blue has from 450 to 495 nanometers. Green also has 495 to 570 nanometers. Yellow has 570 to 590 nanometers. Orange has 590 to 620 nanometers. And lastly, red has 620 to 750 nanometers. So anytime you are given a wavelength of a particular light, you can able to describe whether the light is blue, green, red, or orange. Let's look at the phenomena that our eyes use to detect an object, say the color of an object. So anytime we have a white light, say from a sun, that actually hits an object. So let me use this color to represent the object. There's a reflection that is going on, and the reflection is what we see. So after the reflection, the object tends to absorb some and let some reflect. Should in case the object that you see the color to be red, it means that it's absorbing all the colors that you stated before in the previous slide, and it's only letting you see red. Only the red wavelength is coming out. And that is where you see a color and you determine whether it's red or green. What of white? White means that the light that is coming is hitting the substance and reflecting all of them, making us see it as what? As white. Likewise, black. Black will absorb all of the colors and you will see it as what? As black.